see how we did for 24 and 30. So remember, you only have to create that factor list for 24 and then just see if those are in common with 30. So I have 1, and we know 24. Okay, since 24 is an even number, I know 2 and 12. Okay. Does 3 go into 24, you guys? Look at your multiplication chart. Yeah? Okay, 3. And how many times does 3 go in?
8.
Perfect. And I'm really squishing it now. So let's try to make it smaller. 2, 3. Okay. Does 4 go in there?
Yeah.
Yep. How many times?
6.
Perfect. Okay, so that means you're going to have to test all of these to see if they go into 30 to see which ones are in common. Well, we know for a fact 1 is in common. We know for a fact 2 is in common because this is an even number and 2 divides into every even number. We know for a fact 3 is in common because of our divisibility rule, remember? So the divisibility rule states if these two numbers added together is divisible by 3, then the whole number is divisible by 3. 3 plus 0 equals 3. 3 divided by 3 equals 1, so that whole number is divisible by 3. Okay, does 4 evenly go into 30? No? Perfect. Does 6 evenly go into 30?
No. Oh, yeah, it does.
Yep. So 6 works. Does 8 evenly go into 30? Someone besides Audrey. I know Audrey got this going on. Richard. Does 8 evenly go into 30? Nope. What about 12?
No.
No. Okay, obviously 24 does not. So for this one, your common factors are 1, 2, 3, and 6. Okay. Okay. All right. Next one says find your greatest common factor for the numbers. How did I teach you to find the greatest common factor? What did I do? What did we do? We did those awesome trees, right? Adrian, what are you doing today, honey?
I found half of my past due date work. That's like fractions.
So, in your white binder, do you have any tech stuff that you're supposed to be doing? Nothing for tech? Okay. All right. So, for this one, we're going to have 18. This, so these ones are going to take some time. I'll do one with you, and then I want you to try 2 by yourself. So, 18. Is there a prime number you can pull out? Absolutely. It's whatever prime is easiest for you. Probably, since it's an even number, you're probably going to think right away of 2. Okay, so we're going to say 2 times 9. 2 is a prime number, so you circle it. Okay, 9 is a composite number, which means you know you can pull more numbers out of it. So 9 is 3 times 3. They're both prime numbers. You circle it, you're done with 18. 27's next. Okay. Again, I always try to pull out a prime number first. So I'm going to say 3 times 9. 3 is a prime number, so I circle it. 9 is a composite number, which simply means more numbers you can pull out. So I'm going to pull out 3 times 3, of which are prime numbers. So I'm going to circle it, and I'm done with that number. Now I'm at 36. I think the one that will pop into your head first is maybe 6 times 6. So we're just going to go with that one. And they both pop out prime numbers. So we're going to say 2 times 3, 2 times 3. They're all prime numbers, so you circle them. So you have the setup. I'm going to give you a second to copy down the setup. So this is step 1. Step 1 of finding your greatest common factors is to create a factor tree for each of them. Okay, step 1 is creating that factor tree. Now the key word in this phrase is common. Okay, we're common. This is a theme going on here. Okay, so I got to look at each of these and see what they have in common. I see a 3 here. I see a 3 here, and I see a 3 here. I'm going to circle that 3. I know they all have at least one 3 in common. Okay. I see a 3 here, another 3. I see another 3 here, and I see another 3 here. I'm going to circle them because now I know they all have 2 3s in common. All of them have 2 3s in common. I have a 2 here, but this one does not have a 2. So I know they do not have a 2 in common. 2 is out the door. Okay. So now I know their only common factors that all of them have in common is 2 3s. Okay, which is technically 3 squared, because remember that exponent means you have 2 of that number. Okay, so if I say 3 times 3, right, that will give me my greatest common factor. 3 times 3 equals 9. You box your final answer. My greatest common factor is number 9. Is 9. Okay. And that essentially means, you guys understand that means 9 evenly divides into 18. 9 evenly divides into 27. And 9 evenly divides into 36. And that is the biggest number that evenly divides into all 3 of these numbers. Okay, that's what that means, greatest common factor. So that means this number evenly divides into all 3 of these numbers, and this is the biggest number that evenly divides into all 3 of these numbers. Okay. Let me do number 2 with you as well, and then I will let you try number 3. You guys good? Do you need more time to copy it? try number 2. So I have step 1 listed right up here. Your first step is always to create a factor tree for each number. So I have 4. I think what times what gives me 4? 2. So 2 times 2 gives me 4. They're both prime numbers. Again, a prime number is any number that's only divisible by 1 and themselves. Okay? Once you have your prime numbers, you circle them because there's nothing else you can do with those numbers. They're done. You can't pull out any other numbers. That's as small as it goes. Okay? 8. I gotta make my factor tree for 8. Again, I always pull out my prime number and put it to the left. 2 times 4 gives me 8. I don't know why I just did that. Okay, 4. I know more than 1 and 2 go into it, right? It's divisible by more than just 1. I mean 1 and 4. I just gave you the answer. So I got to break it down. It's a composite number. 2 times 2 equals 4. So I'm going to do 2 more 2's. Circle them because they're prime numbers. Now I have 12. Again, I always pull out my prime numbers to the left-hand side. So I'm going to say 3 times 4. Circle my 3. 4, you can break down. And that is 2 times 2. Circle them because they're my prime numbers. Okay, Aaron, head up. Come on, honey. All right. So that was step 1. Everyone gets a factor tree. The only reason I'm talking through this is because this was a skill taught last unit. So that's why I'm just talking through this instead of explaining how to create this. Because remember, you guys were taught how to create those factor trees last unit. So this, you should already know how to do. The new skill you were taught is how to find the greatest common factor. So this skill, we're just building on our previous skill we learned. So this you should be able to do. This is the new skill I'm teaching you. Okay, or I taught you this unit. All right. So now, we need to find out what do they have in common. I see a 2 here, a 2 here, and a 2 here. So they have this 2 in common. They have at least 1 2 in common. Okay? I see a second 2 here, I see a second 2 here, and a second 2 here. So I know they have at least 2 2's in common. Okay, there's nothing else I can look at because that's all this one has. So it doesn't matter what's in this one or in this one because they have to be in common. It has to be in all 3 of them. So that's it. So now I pull it out. I say all 3 of them, they have 2 2's in common, which is the same thing as saying 2 squared. I have 2 2's. 2 squared is 2 times 2, which equals 4. Final answer. Okay, again, that is saying the biggest number that divides evenly into all 3 of these numbers is 4. There are other numbers that divide evenly into those numbers. So for instance, 2 divides into 4, 8, and 12. But I didn't ask for the smallest number. I asked for the greatest. I'm looking for the greatest. Okay? So what this is telling me, this is the biggest number that evenly divides into all 3 of those numbers. Okay? So with that said, I want you to try number 3. It's on your paper if you can't see these numbers. That says 6, 9, and 18. I want you to try number 3 by yourself, and then we'll come back together. Yeah.
69.
Number 3, right?
Yep, we're on number 3. But your answer was correct.
Correct.
Yeah, so you're good.
And then
Right? I didn't need a pen.
we can do two.
Yeah, but you might need a pen later. You never know.
So they won't have to be one. So it's here. So is that wrong? Yes. Okay. Yeah.
It might be better if I do it this way.
And then what? Two? Nope. You're done. That's three. Yep. Thank you.
I also did number 4.
What, honey?
I also did number 4.
Oh, look at you. You're rocking and rolling it. Alright. Yeah, that's better. Okie dokie, artichoke. Okay. Alright. So if everyone has this correct, I won't even bother working it out because this one's a pretty easy one. What do we get for the greatest common factor? I will take a poll. What'd you get? What? You had all that time and you didn't do it? Leslie, what do you get? Okay. I will give you another 2 minutes. You guys gotta do the work when I say independent work. What? You did it. You got it right. You're good. Okay, can someone tell me who did do it? Why did I say this was so easy? Why would I say something's easy? Audrey.
Do you want to know the greatest common factor for all of them, or
Go ahead, tell me the greatest common factor first.
Okay, I got 3
Yes. Why was it so easy?
because they were all mostly prime numbers besides 18, which is 2 times 9, and 9 goes into like 3 times 3, so those are all prime numbers. And there was only 1, 2, and then the rest were 3. So
Okay. So I like your explanation, but that's even easier than that. All right, so listen for those of you who struggle. Listen why this is so easy. Okay. So 6. You break it down in one step, right? It's 2 times 3. Okay? They're both prime numbers. I'm not going to bother to circle it right now. 9. You break it down in one step. That's 3 times 3. They're both prime numbers. I'm not circling it for now, and you'll see why. It's a waste of my time. Okay. I'm stopping there. Okay, why can I stop there and just say I'm done? Well, I guess you would have to go on if you didn't know 3 goes into that, but okay. The reason why I stopped here for me is, okay, I see there's no 2 over here. So I know 2 is not in common, right? So I automatically have to cross off that 2. That means the only thing can be in common is a 3. That's the only option. So I see I have 1, 3. This 3 can't be in common because there's only 1 here. So now all I have to know, I don't even have to bother doing that tree. All I need to know is, does 3 go in here? Okay? So all you have to do is take your calculator and do 18 divided by 3. As long as 3 goes in here, then 3 is your answer. Okay? If 3 didn't go in there, then there is no greatest common factor. If it would have plugged out that 3 didn't divide in there, the answer would have been there is none. Okay? But that's how I just could stop right away. After I got to 9, I could say, oh, it's just 3. So that's using some critical thinking skills without wasting all the time doing extra work. So like that's when I say that's extra work. You didn't even have to do the 18. That's extra work. Okay? So now, number 4. So maybe try using what Miss Fisher just taught you to do number 4. So I'm just going to set up the first one, and if you can't, that's fine. You can draw out the trees for all of them. But think about what I just taught you. So 15 pulls out just 2 numbers, right? So it's 3 times 5. So there's only 2 possible numbers you're testing that needs to be in common for the other 3 numbers. Okay? If 20 is divisible by 5 and 25 is divisible by 5 and 30 is divisible by 5, which you guys should be able to tell me like that if you know your divisibility rule for number 5, which I know you all should know because I've said it 5,000 times. Okay? Then you would know for a fact that, 5, whether it is or not a common factor. Then you just simply take your calculator and try, is 20 divisible by 3? And if 20 is not divisible by 3, then guess what? 3's canceled out because it has to be common with all the numbers. So this is another one. Instead of taking like 10 minutes to do all the trees and think it through, you can figure it out in like 5 seconds if you wanted to, using critical thinking skills. So I'll give you time. You can do it whichever way you want, but you can figure this out very quickly. You could. We're on number 4. Yep, number 4. Yes, honey. Yep. Yep. Thank you so much. So just because for the sake of time, we only have 3 minutes left to class.
Really?
We sure do. I know class goes by way too fast now. I'm sorry, you guys.
No, don't be sorry.
That's why I'm trying to teach you these techniques so we don't have to. We only got through a couple more problems today. So So I'm trying to teach you these techniques. So what did you guys get for the greatest common factor for 15, 20, 25, and 30? I'm taking a poll. Richard. Just tell me. It's okay. You could be right or wrong. Doesn't matter. What'd you get? Okay, guess. Give me a number. Okay, Leslie, what'd you get? Guess. Give me a number. 10. What'd you get, Aaron? What'd you get, Audrey?
I didn't finish, but I'm guessing 5.
What'd you get?
I didn't finish either.
What are you guessing?
5.
Okay, what'd you get? Okay, so majority says 5, and the correct answer is 5. Okay, so the only possibility, so let's think this through. Okay, 15 I broke down. Okay, so remember, when you're finding the greatest common factor, you would multiply those prime numbers. Hold on, time out. You would multiply your prime numbers together. So the only possible answers are this. It could have been a 3. It could have been a 5. Or if you're multiplying them together, it could have been a 15. They're the only ones it could have been. 10 ain't even an option here, y'all. Okay? Because you got to roll with what you got with 15. Because it has to be in common for all of them. So like if 3 would have been common for all of them, you could have had a 3. If 5 would have been in common for all of them, you could have had a 5. If 3 and 5 would have been in common for all of them, then you would have had a 15. Yes, Aaron?
We're doing this tomorrow.
We're going to continue on tomorrow. But the answer was 5. 3 does not go into 20, you guys. 3 does not go into 20, so you stop right there. You know it's only 5. Divisibility rule of 5. If it ends in a 0 or a 5, it's divisible by 5. All right?
Where is she?
And with that, it's a wrap for the day.
I'm ready to go home and take a nap. Although my math class is last period.
All right. Good job again, you guys.
I'm just gonna get a head start on the halls.
Yeah, no, you're good.
Have a good night.
You too.
What the?
You can't leave.